Hi, this is Tim Davis representing General Dynamics Mission Systems Route 66 Cyber CASB. And I wanted to talk to you today about the three ways that CASBs attempt to solve the problems that we talked about in a previous video. So the first way that a CASB is going to attempt to control traffic that's going back and forth between cloud applications and endpoints is through APIs. And APIs actually aren't going to involve the endpoints, they're going to involve communication directly between the CASB and those sanctioned applications to look for things like data loss, data patterns that would trigger a DLP policy, that would look for files that are shared in between applications or shared with third parties, and anything else that may be a security API might reveal to a CASB and then either allow it to report on or possibly take some kind of action. So APIs definitely have some positives. They're direct CASB to application, so they're easy to deploy because they don't involve any type of endpoint change. They don't involve the user really at all, so there's nothing from a behavior perspective that the user has to do. They can scan data that's already in cloud applications. So if a cloud application like Office 365 or Salesforce has already been deployed, and then you're coming back and implementing a CASB type security apparatus on top of that, you can use the APIs to scan the data that's already in those cloud applications. And then most of the time APIs, and again this depends on the application itself, are able to take actions based on findings. Like there's a file that's shared externally that contains sensitive information, so we want to remove that sharing. There's information in a file that we don't want out in the cloud, and so we can encrypt that file or quarantine that file. But API scanning does have some drawbacks. It gives you no ability to do access control, so you can't prevent users from accessing applications that you don't want them to access. And it gives you either no or possibly very limited user visibility into what users are doing once they get into those applications. Data loss protection is not going to be in real time when you deal with an API. No matter how fast an API is, it's always going to be after the fact. Studies show that within the first 30 seconds of a file being put into a unsecured cloud location, that's usually 90% of the time that's when it's gone, within those first 30 seconds. So if you're counting on APIs only, you're racing the clock to see if your API can catch it before that malicious user or other third party that you don't want to have access to that data gets to it first. And then APIs don't offer you any control for unsanctioned applications. They can only support applications that you're paying a subscription for. For example, Box is not going to let you do API hooks into their application if you're not paying them a subscription to do that. And then finally, the APIs are only able to do what the applications let them do. So in cases like Salesforce, Google, Microsoft Office 365, for example, they offer a very rich, very robust security API. There are other applications out there, Workday being one, that don't offer very much in terms of security, in terms of what their APIs can do. So the amount of control and visibility that you're going to get from an API only solution is going to be pretty limited, or can be pretty limited, based on what the application allows you to do. So that leads us to a second way that CASBs will attempt to solve the cloud problem of controlling information and where it flows, and that's going to be the forward proxy. Pretty straightforward. The user initiates a connection. That connection gets routed in some way, shape, or form through a central policy engine midpoint, and then all traffic to any application must pass through that endpoint where policies can be enforced. So forward proxies typically are implemented in one of three ways, either through an endpoint agent, through a proxy autoconfig or a pack file that's downloaded to the endpoint, or through an in-path interception like through a secure web gateway, for example. These can control access to applications, so now we're back to being able to do real-time contextual access control. Any data loss protection that is supported here can also be done in real time. And then you can even take actions based in real time. Block a download before it happens, block an upload as it's attempting to occur, those types of things. So it's a very powerful tool. We've moved into this real-time world, but forward proxy does have some drawbacks as well. First and foremost, it only works for managed devices. If I don't have control over the endpoint and where its traffic is going, then I don't have the ability to force it through that control point. So if I can't do that, then I don't have the ability to implement forward proxy for that particular device. It does require forced routing of all traffic through an inspection point, which may cause performance issues. Forward proxies can have scaling concerns. When traffic is forced through a proprietary data center or it's forced through an on-prem appliance or set of appliances, those can become bottlenecks and scaling concerns. And then forward proxies can't do anything about data at rest. So the third method then is what we call a reverse proxy. And this is a little more subtle, so I'm going to walk you through it. But the user initiates a connection to the application. In this case, it's a SaaS application, let's say Office. And then Office recognizes that user's name and knows that it's configured to connect that user through the CASB. So the user hasn't done anything differently. They've gone directly to the application, but the application is now doing a redirection to put the CASB in the path of that user session. So now the CASB is in the path. The CASB is going to now mediate the single sign-on process through any SAML compliant identity provider, whether that's the CASB itself, whether that's Okta, ADFS, OneLogin, Ping, doesn't matter. Once that sign-in is completed, then the SAML federation is going to pass the user session back to the application. It's going to pass it back to the CASB, and now the CASB is in the path between the user endpoint and the application. So now you can do all those types of real-time access controls, data loss protection, without the user having had to do anything differently. So reverse proxy has some great advantages. It's very easy to deploy because the configuration is all in the application. I don't have to do anything to the user endpoint, or I don't have to modify the user's behavior in order to be able to get in the path and do that real-time inspection, real-time contextual access control. It also supports unmanaged devices, right? This process can work exactly the same whether I'm coming from a managed endpoint, an endpoint that my organization has issued to me and that they have control over, or whether I'm coming from a third-party machine or a BYO device, those types of things. So it's very powerful from that aspect as well. And just like we talked about, we can now control access to all those applications in real time. We can allow or disallow access based on different things like the username, the device they're coming from, the location they're coming from, the time of day. And if we do allow access, we can do data loss protection in real time and take action on user behavior in real time as well. Of course, there are a couple of drawbacks to reverse proxy. So it only works for sanctioned or owned applications. You notice there's no arrow over to the far right because reverse proxy is not going to be able to get in the path on an unsanctioned application because there's no ability for that application to know that it needs to redirect those sessions. And typically reverse proxy requires a single sign-on. Some people might consider that a drawback. I would consider it more of a caveat because most users like single sign-on because that's fewer passwords that they have to remember, and it's typically much more convenient for those users. So in the case of the GDMS Cyber CASB, which of these are they going to use to help you secure your cloud applications? The answer is all three, because all three address a unique set of cases. For your sanctioned applications, whether they're SaaS or IaaS hosted or even maybe hosted on premise, reverse proxy is going to give you that real-time contextual access control in concert with APIs to let you go back and scan data that's already there and do some additional security measures beyond what the reverse proxy might allow you to do. And then for the case of the unsanctioned applications, that's where the forward proxy is going to kick in and allow you to prevent data from going from your managed devices out to those applications that are in the cloud that you're not wanting people to use, and give you that type of control, whether that's blocking those applications making them read-only, or applying DLP policies to the traffic that goes to and from those applications. So that's the three methods that CASBs will use to attempt to control and give visibility into data that's moving into to and from cloud applications. In particular, this is the Route 66 Cyber CASB is going to use all three of these to give you the best possible security as you move into the cloud world. Thanks for listening.